A girl uses a rope to move a giant sofa across her living room floor. She moves the sofa with a constant velocity, pulling with a force of 200 newtons. The sofa has a mass of 30 kilograms. Number 1. Identify the forces acting on the sofa. Draw a qualitative force diagram for the sofa. We know we have the force of gravity pulling it down. So the force of gravity by the earth on the sofa. We also have the normal force by the ground on the sofa. We have a force of tension pulling the sofa to the right, so force of tension by a rope on sofa. And finally, we have a force of friction to the left. By the ground on the sofa. You'll notice here that we're looking for the forces acting on the sofa. So every force that I've drawn is acting on the sofa. Any force acting on another object doesn't belong in a force diagram for the sofa. Draw a system schema for the sofa. We'll start with the sofa, and we know that the earth is interacting with a force of gravity. The ground is interacting with the sofa with the normal force and a force of friction. And the rope is pulling the sofa with a force of tension. So, create a force table. With a force table, we're going to take a look at the forces, what types of forces we have, and then we're going to look at the components in each direction. The x direction, which is horizontal, and the y direction, which is vertical. So let's list the forces that we have looking back at our system schema and our force diagram. We have the force due to gravity, we have the normal force, we have the force of tension, and then we have a frictional force. Now we're going to look at each component of these forces. Now the x direction, we have to choose a positive. So we have the right and the left. We'll make the right a positive direction, and we'll make the left a negative direction. Looking at the y direction, which is vertical, we're going to say that the up is positive and down is negative. So let's look at the force of gravity. We know that this is pulling the sofa down, and the down is the negative direction, so this is negative 294 newtons. We know that there's no horizontal component, so the gravitational force in the x direction is 0 newtons. Let's look at the force of tension. So we know that the tension that the girl is pulling is 200 newtons to the right. Now we know that the right is the positive direction, so this is going to be a positive 200 newtons. We also know that she's pulling us only to the right, so the vertical component is going to be 0 newtons. Looking down, we don't know what the frictional force is, but we know that it doesn't act up and down. It's going to be parallel to the surface. So the vertical component will be 0 newtons, and the horizontal component will be some unknown amount. Looking at the normal force, we know that the normal force acts perpendicular to the ground, so it has to be up and down, because the ground runs from side to side. We know it has no horizontal component, but we don't know what the vertical component is. We know that the sofa is moving at a constant velocity, and if it's moving at a constant velocity, there's no acceleration. and if there's no acceleration, then the forces must be balanced. Remember, a constant velocity means that the forces are balanced. If the forces are balanced, the overall force in the x direction has to be 0 newtons, and the overall force in the y direction has to be 0 newtons. So if we know that the total force in the x direction is 0 newtons, whatever the force of friction is has to be the exact opposite of the force of tension pulling it to the right, because these forces are 0. So the opposite direction would be to the left, so it would be negative, but it has to be the same magnitude, so it's going to be 200 newtons in the negative direction. We also know that if the overall forces in the y are 0 newtons, then we know that the normal force must act in the opposite direction of the force of gravity and be of the same magnitude. So it's going to be 294 newtons, and in the positive direction because it's up. Now we have our force table, which tells us the magnitude and direction of all of our forces and their components. We use that to make a quantitative force diagram. So a quantitative force diagram tells us the magnitude of the vectors as well as the directions, whereas the qualitative force diagram only tells us the direction of the forces. As we've done with all vectors so far this year, we're going to need to scale them down. So I'm going to choose to make a scale of 50 newtons equaling 1 centimeter. Now I have to convert our forces over here in our force table so that I can draw them over here on our graph paper. First, let's convert and find out how long our force of gravity is. So the force of gravity we know is negative 294 newtons. We know that 50 newtons is equal to 1 centimeter. The newtons divide, and we're left with a length of negative 5.88 centimeters. The negative sign just tells us that it's down. So if I start right here, I need to draw a 5.88 Newton vector downwards. And that's our force of gravity, negative 294 newtons. Next, I'm going to choose our force of tension. So the force of tension is 200 newtons, positive, so it's to the right. A vector that's going to be 4 centimeters long. So I draw a vector that's only 4 centimeters long. So this was our force of tension. Next we'll do the normal force, which was 294 newtons in the positive y direction, which is up. So this is going to be a 5.88 centimeter vector. And that's our normal force. Finally, our negative 200 Newton vector will be negative 4 centimeters. So I go 4 centimeters to the left. And that's our force of friction. This is good because we have balanced forces. So when we add all of our vectors together, we should get back to the origin where we started. Okay, we could also use our quantitative force diagram simultaneously with the force table to solve this problem. So first we write down our forces that we know. Force of gravity is equal to 9.8 times the mass of the object, which is 30 grams. So 9.8 times 30 is negative 200 94 newtons because it points downwards, and downwards is negative. We know it doesn't have a horizontal component. We don't know anything about the normal force right now, but we do know that the force of tension is 200 newtons, and it's positive because it goes to the right, which is our positive direction. So I'll use the same scale as before. 50 newtons is equal to 1 centimeter. I'll take the first gravitational force that I have and I'll convert it to centimeters. This vector becomes negative 5.88 centimeters. So I draw a vector downwards. That's negative 5.8 centimeters. So that's our force of gravity. Well, the other force that I know is that we have a 200 Newton force to the right. And converts to a 4 centimeter vector. So I'm going to make a 4 centimeter vector that points to the right. And that's my force of tension. I know that there's no force of tension in the y direction, so that component is 0 newtons. Again, I know that our forces are balanced, so the total force in the x direction is 0 newtons, and the total force in the y direction is also 0 newtons. So I can think when we add vectors, we place them tip to tail, and if they add up to 0, I'm going to have to go back to where we started. So in order for me to go back to where we started, we have to have a vector that goes up this much, and goes to the left this much. Well, I know this upward vector, I only have one force looking back to my qualitative force diagram that goes up, and that would be the normal force. When I measure it, I see that the vector is 5.88 centimeters. So now I just have to convert the length of this vector to newtons. So 5.88 centimeters. 1 centimeter is 50 newtons. This ends up being a 294 Newton force. So I know that that's in the positive direction because it points up. So we have 294 newtons in the positive direction and no component horizontally. Well, if I measure this horizontal component to the left, I see that it's 4 centimeters long. Find out that that's a 200 Newton vector. But because it points to the left, it's going to be negative. And we have no vertical component. So here I've found all my forces using the picture before I use the table. Now I can always check my answer and say, I know that we're supposed to have 0 newtons. So 0 plus 0 plus 200 newtons plus negative 200 newtons equals 0. And I do the same thing with my vertical components. Negative 294 plus 294 is 0, plus 0 is 0, plus 0 is also 0. So we get all of the forces adding up to 0 newtons. Remember, you can use either method. You can draw the picture first, or you can draw the table, fill in the table first. The important thing is that the forces must add up to 0, and you should be able to check that.